Okay, hi. I am this is Daivadianta. My student is 23, 61 to 0 and I'm from the BCI. It's 23, and I'm here to my assignment for the subject IoT. Let's get to it. The objective of the task is to visualization of attendance trend, and then correlation analysis, and then future recommendation. Uh, the The study case is that we got the data of the temperature, occupancy, and light in a room for each hour. Here's the data set. The timestamp for the time written data, the ID of the room, the occupancy count, the people count, temperature, in Celsius, and the light intensity in lux. Here, here's I'm loading the data, and then getting the info of the data timestamp so in string, so I need to convert it in the date time later on. Then is the statistic description, the mean, standard deviation, the count, and the max. And then here's I'm displaying the unique value for each column. Then let's just get into the first part, the attendance visualization. Here I convert the timestamp to datetime first, so that it can be visualization. It can be grouped by date. Which is I group by date. The first March, it's okay, total occupancy is 61, I guess, and then the second March is 50, and the third is 40. And here's the visualization for each hour in each day. First day, the second day, and the third day. The first day, it's always start at 8 o'clock, 8, 9, 10, 11, 12, 1 p.m., 2 p.m., 3 p.m., 4 p.m., and 5 p.m. Let's go. So from the analysis, for the analysis, can be concluded that the busiest hour is always at 11 o'clock, and the quiet hour is always at 14 and 17, or 2 p.m. and 5 p.m. Uh, my prediction, or my assumption, uh, the in the early hour, people gradually entering the room one by one. So in 11 o'clock, the room is occupied at most, and then during the afternoon break, people come out one by one also until the 2 p.m. is it lasts. Then people come back to the room. Some of them are pair of the workers because they have the higher status in the company, and then at 5 p.m. they clock out everyone, so there's no one in the room. Okay, for the correlation analysis is the Spearman method, and here's the analysis. The correlation between the occupancy and the temperature is zero point 0.6, while the occupancy and the light is 0.88. It is all positive, so whenever the occupancy is going higher, the temperature and the light is also going higher. And what does that mean? Yes, on this table, if I take a look in this table, then the correlation between the temperature and occupancy is moderate, and the occupancy and the light is a strong correlation. Also, this another visualization for the scatter plot that it goes to the right and upright, then the correlation is positive. The x is positive, the y is positive, so it's positive. For the last is screen energy recognition. Here I visualize first the trend for the uh, occupancy for the blue, and the orange is the AC, what the temperature. It's it's pretty much the same, right? More people, higher the room temperature. So, question number one is, when should the AC usage be reduced? Is when the room is less occupied. It's pretty easy as that. So the second one is the trend for the light intensity. It's also the same, pretty much the same. Right? So this one analysis, are the light on optimally? It is optimal because when the room is less occupied, the light is reduced. For recommendation based on the data is to reduce the usage of light. We can utilize the natural energy like the sunlight. So we only use the light on the room that is not exposed with the sunlight, and the unused room also can be turned off the light. The second one is to adjust the usage of AC periodically. Company can set the standard for the room temperature, then employee can change it based on the occupancy of the room, or make automation of the room temperature based on the occupancy. That needs to be initialized when building the office. The last thing is my assumption based on the data. My recommendation is to maximize the energy efficiency is when initialing the company starting building the office by themselves. Uh, Architecture wise, can make the insulation for each room, or make use of the natural energy for the window, like sunlight, ventilation, to make use of the breeze of the wind, etc. But the strategy is high on the capital cost, so but the long term of energy efficiency is the best. And yeah, let's conclude my analysis for the study case from Smart Office. Yeah, thank you.